We hear about the dream of a clean energy economy all the time, right? And one molecule keeps popping up in that conversation, hydrogen. But, turning that dream into a reality, that's where the hard science has to meet some really ambitious policy. The US approach is built on what it calls strategic realism. Basically, a plan designed to bridge the gap between the cold, hard laws of physics and the decarbonized future we're all aiming for. So let's break down what that actually means.
You've probably heard this promise. Maybe you've even seen it in a movie. Cars that run on nothing but water. It's a really powerful idea, isn't it? But is that really how hydrogen energy works? Honestly, this is one of the biggest misconceptions we've got to tackle right up front.
And this gets right to the heart of the physics. That dream of a car running on water, it slams right into a wall called the first law of thermodynamics. You just can't get energy for free. See, water is the stable end product of burning hydrogen. Think of it like the ash that's left over after a fire. To get useful hydrogen back, you have to pump energy into the water to split it. And that makes hydrogen an energy carrier, not an energy source. It's much more like a rechargeable battery than a tank of gas.
Okay, so if it's just a carrier, what's the point? Well, its purpose is to be this incredibly versatile connector for the whole clean energy economy. The big idea is to take clean electricity, whether it's from wind, solar, nuclear, you name it, and use that to produce hydrogen. Then, that hydrogen can become the fuel for all the parts of our economy that are really, really hard to power with just batteries. And the goal here is massive. We're talking about a 5-fold increase in clean hydrogen production, from 10 million metric tons today to 50 million by 2050, all to help us get to net zero.
So to really get our heads around this whole strategy, we're going to focus on 3 core insights. First, we'll look at the diverse menu of options for actually making clean hydrogen. Second, we'll tackle the huge infrastructure challenge of moving and storing it. And third, we'll see how we can target the right emissions to get the biggest bang for our buck. Let's kick things off with production.
All right, insight number 1, the production menu. Making clean hydrogen isn't a one-size-fits-all kind of deal. Just like the subtitle says, it's not about one single color of hydrogen. There's a whole menu of pathways to get there. The heart of the US strategy is really just pragmatism. Instead of betting the farm on a single technology, the plan is to use all the unique resources we have across the country, from all that sunshine in the Southwest to the crazy wind in the Great Plains. It's a true all-the-above approach. We're not picking winners, we're using everything we've got. So let's look at the first option on the menu, electrolysis. This is that process we talked about, using electricity to split water into hydrogen and oxygen. Now, when that power comes from renewables like wind and solar, we call it green hydrogen. If it comes from nuclear power, it's often called pink hydrogen. But either way you slice it, it's a zero-carbon process. The second pathway uses our existing natural gas infrastructure. There's a process called reforming that creates hydrogen from gas, but it also produces CO2. So, to make it clean, you have to capture that CO2 and store it deep underground. We call this blue hydrogen, and it's a really important bridge technology in the overall strategy.
And then there's a third major pathway called gasification. This process can convert all sorts of organic materials, think agricultural waste, stuff like that, into hydrogen. It's pretty cool. You're essentially turning something we'd otherwise just throw away into a clean energy carrier.
Now look, it doesn't matter which of these pathways we use. The single biggest hurdle is cost, and that's why the Department of Energy launched what they call the hydrogen shot. It's a goal that's both incredibly ambitious and super easy to remember. Bring the cost of clean hydrogen down to $1 for 1 kilogram in 1 decade. Hitting this 1-1-1 target is the absolute key to making clean hydrogen competitive with everything else.
Okay, so we've made the hydrogen. Awesome. But our second big insight tackles the next huge question. How in the world do you move and store the lightest, smallest molecule in the entire universe?
This is a serious physics challenge. By weight, hydrogen is packed with energy, but by volume, it's incredibly light and fluffy, which makes it a real pain to transport efficiently. As you can see, we've got 4 main options: pipelines for moving huge amounts, tube trailers for shorter distances, special liquid trucks that make it denser, and even chemical carriers like ammonia for shipping it stably over long hauls.
And storing it is just as critical. For grid-scale stability, the real game changer is large-scale geological storage in places like these giant underground salt caverns. Seriously, think of these as massive underground batteries. We can store enormous amounts of hydrogen made when the sun is shining and the wind is blowing, and then use it to generate power when it's not.
And that brings us to our third and final insight. I mean, with all this effort to produce and move and store hydrogen, where is it all going to go? Where will it actually make the biggest difference?
So, this is a crucial point. Clean hydrogen is not meant to replace the gasoline in your passenger car. Its real superpower is in decarbonizing what we call the hard-to-abate sectors. We're talking about heavy industries like steel manufacturing and making ammonia for fertilizer. We're also talking about heavy-duty transportation, things like long-haul trucks, huge cargo ships, and even aviation. These are all areas where batteries just aren't a practical solution right now.
And hey, the benefits here aren't just environmental. Building this new hydrogen economy is projected to create 100,000 net new jobs right here in the U.S. by 2030. That's everything from manufacturing and engineering to day-to-day operations. And if we look even further out, the economic potential is just enormous. The domestic hydrogen market could be generating up to $140 billion in annual revenue by 2050, all while boosting our energy independence by using our own resources.
You know, this isn't just some pipe dream for the future. The market is already moving. Shipments of fuel cells, that's the key tech for turning hydrogen back into electricity, have seen a 15-fold increase since 2015. The momentum is definitely building.
So, we have the what, the how, and the where. But a strategy on paper is one thing. What is the path forward to actually making this a reality? What does that look like? Well, it means we have to start tackling the non-technical barriers.
It turns out technology alone isn't enough. We have to tackle 4 other critical areas. First is cost, which we already talked about with the hydrogen shot. Second is safety and codes. We need consistent, harmonized regulations so everyone's on the same page. Third is workforce. We have to train a whole new generation of technicians. And fourth is energy justice, making absolutely sure the benefits of this new industry reach communities that have been left behind in the past.
Ultimately, success is going to hinge on collaboration. The strategy document is crystal clear about this. This future has to be driven by real science, not the pseudoscience of water-powered cars that we talked about at the beginning. And that requires a real partnership between government, industry, and academia, all pulling in the same direction. So at the end of the day, the U.S. has a pragmatic, science-based roadmap. It recognizes the tough challenges of physics and economics. It treats hydrogen not as some magic bullet, but as a strategic tool for decarbonization. The science is there. The plan is there. The final question, as this slide asks, is really a human one. Can we all collaborate effectively enough to actually build this future? Thanks for watching.